Hi everyone, this is Dr. Siva Nageswara Rao, working as Assistant Professor of Mathematics in the Department of Mathematics and Management Science, VNR VJEC. In previous two lectures, I explained about how to find eigenvalues and corresponding eigenvectors of the given square matrix in two different cases. Case 1, if the eigenvalues are distinct. Case 2, out of 3 eigenvalues, 2 eigenvalues are repeated and 1 is distinct. Today I am going to explain about one more content in Unit 2, that is diagonalization of the given square matrices. Now what is the diagonalization of the given square matrix? We will take capital A is a matrix of order n by n. When do you say matrix A is said to be diagonalizable? The condition is there exists an invertible matrix of order n by n denoted by capital P and the diagonal matrix capital D such that the product of P inverse multiplied by A multiplied by P is equal to diagonal matrix, then only the matrix capital A is said to be diagonalizable. Here in the definition, the matrix capital P is said to be model matrix. In the definition, the matrix capital P is said to be model matrix and the matrix capital D is called the spectral matrix. Here, what is the beauty of capital D? Capital D is a diagonal matrix in which the diagonal elements are the eigenvalues of capital A. Here I am taking generalized case, that is capital A is of order n by n, hence there exists n eigenvalues. What is capital D? Capital D is a diagonal matrix in which the diagonal elements are the eigenvalues of capital A. And what is capital P? Here if you are observing capital P, x1, x2, x3 and so on, xn. It means corresponding to each eigenvalue lambda I, corresponding to each eigenvalue lambda I, there exists the corresponding eigenvector xi. There exists the corresponding eigenvector xi. Therefore, we will write capital P as first column as first eigenvector corresponding to first eigenvalue. Similarly, second column is second eigenvector corresponding to second eigenvalue. Third column is third eigenvector corresponding to third eigenvalue and so on, nth eigenvector corresponding to nth eigenvalue. This is how we will form the matrix capital P. Capital P is a model matrix in which the columns are eigenvectors corresponding to the eigenvalues of capital A. Now we will see example how to diagonalize the given matrix capital A. Anyway, in previous class I already explained about for the same problem how to find eigenvalues and eigenvectors. Now I am going to explain how to write capital P, how to find P inverse, how to multiply P inverse with A and with P. Finally, we will get the diagonal matrix. Now what is the interesting point in capital D? The diagonal elements in capital D are the eigenvalues of capital A. Anyway, here I am going to write what are the eigenvalues we obtained for this matrix in previous class. That is, the eigenvalues are lambda 1 is equal to 3, lambda 2 is equal to 6, lambda 3 is equal to 1. Corresponding to this, corresponding to lambda 1 is equal to 3, the eigenvector is 0, 0, 1. Corresponding to lambda 2, the eigenvector lambda 2 is equal to 6, the eigenvector is 1, 2, 0. Corresponding to lambda 3 is equal to 1, the eigenvector is 2, minus 1, 0. So, in previous class, these are the eigenvalues and eigenvectors we obtained for this matrix. Now I am going to write capital P. What is capital P? Capital P is the first eigenvector corresponding to first eigenvalue. So 0, 0, 1. Next one, the eigenvector, second eigenvector corresponding to second eigenvalue. What is that? 1, 2, 0. And third eigenvector corresponding to third eigenvalue, 2, minus 1, 0. Now here, our aim is to find determinant of this model matrix capital P, which contains the eigenvectors corresponding to eigenvalues of capital A. Now here, the determinant of capital P is equal to 2. The determinant of capital P is equal to minus 5, not equal to 0. Therefore, P inverse will exist. P inverse will exist. Now, what is P inverse here? P inverse is equal to, anyway, in lower classes we studied how to find inverse of the given matrix if it is non-singular. That is, if I am taking capital A is a non-singular matrix, then it's A inverse. A inverse is equal to adjoint A divided by det A, comma det A not equal to 0. In the same way, I am going to calculate P inverse. The formula is adjoint P divided by det P. Therefore, 1 by det P, that is minus 1 by 5 into, this is what you will get adjoint matrix. The adjoint matrix is minus 2, 1, 0, 0, 0, minus 5, minus 1, minus 2, 0. This is how we will calculate inverse of the matrix capital P. Now I am going to multiply P inverse with A with P is equal to, what is P inverse just now we obtained? Minus 1 by 5 into minus 2, 1, 0, minus 2, 1, 0, 0, 0, minus 5, minus 1, minus 2, 0. This is P inverse. Now, the given matrix capital A, 2, 2, 0, 2, 5, 0, 0, 0, 3. Again, we will multiply this with capital P. What is capital P? Model matrix 0, 1, 2, 0, 2, minus 1, 1, 0, 0. If you are multiplying these three matrices, later multiply that resultant matrix with minus 1 by 5, you will get the diagonal elements as 3, 0, 0, 0, 6, 0, 0, 0, 1. This is what I said. The interesting point in this diagonal matrix capital D is the diagonal elements are the eigenvalues of capital A. So this is called diagonalization of the given matrix capital A. So this example is related to a matrix with distinct eigenvalues. Now I am going to explain one more example, diagonalization of the given matrix if out of 3 eigenvalues, 2 eigenvalues are repeated and 1 is distinct. And one more thing you need to remember, my dear friends, assume that after finding eigenvalues and eigenvectors, whenever you are creating the model matrix capital P with eigenvectors, if det P is equal to 0, then the given matrix is not diagonalizable. Please keep it in your mind. This is one more example. Earlier we already discussed. This matrix is 2 eigenvalues are repeated and 1 is distinct. Now, corresponding to this matrix, the eigenvalues are lambda 1 is equal to 3, lambda 2 is equal to 1 is equal to lambda 3. The corresponding to lambda 1 is equal to 3, the eigenvector is 1, 1, 0. Corresponding to lambda 2 and lambda 3, the eigenvectors are 1, 0, minus 1, 0, 1, minus 1. 0, 1, minus 1. So, I am going to create the model matrix capital P with these eigenvectors x1, x2, x3. Therefore, the capital P becomes 1, 1, 0, 1, 0, minus 1, 0, 1, minus 1. Now, immediately we will calculate determinant of the matrix capital P. That is, capital P determinant is equal to 2, not equal to 0. Therefore, P inverse will exist. Clearly, determinant of P is equal to 2, not equal to 0. Then determinant is not equal to 0. Hence, the matrix is diagonalizable. Sorry, the matrix is invertible. So, capital P inverse is equal to 1 by det P multiplied by adjoint P. So, what is det P? 2. 1 by 2 multiplied by, here the adjoint matrix is 1, 1, 1, 1 minus 1 minus 1, minus 1, 1 minus 1. So, this is P inverse. 1 by det P multiplied by adjoint P. Now, I am going to multiply P inverse into A into P is equal to, P inverse is 1, 1, 1, 1, 1 minus 1 minus 1, minus 1, 1 minus 1, multiplied by A value, that is 2, 1, 1, 1, 2, 1, 0, 0, 1. This multiplied with the capital P, model matrix. 1, 1, 0, 1, 0, 1, 0, minus 1, 1. If you are multiplying these three matrices, you will get the resultant matrix by multiplying with 1 by 2. By multiplying with 1 by 2, you will get the matrix as 3, 0, 0, 0, 1, 1, 0, 0, 1. Sorry, here this is 0. So, this is the diagonal matrix capital D, in which the diagonal elements are the eigenvalues of capital A. This is how we will diagonalize the matrix capital A. A small recap. What is the process to find the diagonalization of the given square matrix? Step number 1, the given matrix should be a square matrix. Step number 2, find out determinant of the characteristic matrix equating to 0. You will get the characteristic equation. Step number 3, find out the eigenvalues. You will get 3 eigenvalues. Why? Because in generally always we are taking 3 by 3 matrix. You will get 3 eigenvalues. Corresponding to 3 eigenvalues, you will get 3 eigenvectors. We will arrange these eigenvectors as column vectors in the model matrix capital P. We will find out immediately determinant of P. Determinant of P should not be equal to 0. If it is equal to 0, then the matrix is not diagonalizable. Why? Because P inverse does not exist. So, if determinant of P is not equal to 0, we will proceed further. Find out P inverse, adjoint P by det P. We will get P inverse value. By multiplying P inverse with A with P, we will get the diagonal matrix. What is the specialty of this diagonal matrix? The diagonal matrix in which the diagonal elements are eigenvalues of capital A. This is the process to diagonalize the given matrix. Here I am providing few worksheet problems. Diagonalize the following matrices. Here I gave 2 model problems, a matrix with distinct eigenvalues, a matrix with repeated eigenvalues. Please try to solve this. In next class, I am going to explain one more topic in unit 2, that is Cayley-Hamilton theorem. In that class, we are going to study about what is the statement of Cayley-Hamilton theorem and what are the applications of Cayley-Hamilton theorem. Thank you.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.